So this is hi, welcome back. Sorry, Math 3-1 class here, Mr. Allen. So this is gonna be a quick little video on just what this change of base identity is. Now, we didn't really talk about identities yet, but identity is just kind of an expression that says one side is equal to the other side that you can always change between the two at will if you wanted to. Now, the reason for this identity is that some calculators, like I was saying, does not have the ability to have this change base where you have like a log and then you're allowed to put something here and then you can put something in here, right? Some calculators are allowed that. Like if you have one of the newer calculators, that will be there. There's no way to disable that anymore. So all calculators are allowed this little change of base as long as it's able to do it. Like I was saying before, these older calculators here, the black ones, the TI-83 pluses, they don't allow this or don't have this functionality. It's not that they don't allow it. They just don't have it. No one's going to update the operating system. So if you ever get a question that involves a different base other than 10, because that's all we have here, or natural logs, because you have the two buttons on the bottom, you're going to have to use what we call the change of base formula, which you can also change. You can change this to any base you want. It can be base 2, base 3, base 5, or you can isolate or calculate something that has a different base that your calculator can't do. Right? So we can use this notation or this identity to do so. So this is an example down here. This is a base 4. So I could just punch that in my calculator if I had the base 4 button, but if I don't, I can use the base 10 log to do this. So I can go base 10 of 1024. Now the base 10 of 1024 is not a very nice number, right? But once you divide it by log base 4, it ends up being a much nicer number, right? So I can go here in my calculator and say, okay, log 1024. I'll show you what number it looks like. Not very nice, but if I divide that by log 4, it ends up being exactly 5. Okay? Which is just saying, okay, 4 to the power of 5 is 1024, which we know. Which we should know is one of the identities, or it's mathematical truth. Sometimes you might see it where you might divide a log over to the other side, and you're like, how do I combine these two logs together? Now, you can't just divide these two things that are within the log here. There is a rule for this later on where you, if there is a division within the log, you can split it apart. But there is no rule for just dividing two logs unless they have the same base. In this case, because this is base 2, this is base 2, I can combine these using this identity. Now, like I was saying before, this doesn't always have to be base 10, this doesn't have to be base 10. But once it goes back into this identity, you notice that whatever was here disappears, it's gone. There is no base 10 over here on this other side. So this base 2 disappears, and this just becomes a log base 4 of 1024, which is the exact same math we had before. So this should end up being 5 as well. You notice that this 4 is on the bottom here, the 4 is on the bottom here. Right? This 4 is on the bottom there, it's on the bottom there. So this 9 is on the bottom here. So I should be able to write this as log 9. We'll use base 10 here. You can change it to whatever base you want. Base 5, that doesn't really matter. Base 10, because that's what my calculator is, the easier button. And then on the top, put log 27. I can punch in my calculator and get a number. And I can verify those two things are the same thing by typing both in my calculator. So I can go log 27. Oop, make sure to close that bracket off. Divide by log 9. Right? 1.5. Then I can also just go math 9 and put a little 27 here. So what to the power, 9 to the power of what is equal to 27? It's 1.5 as well. So this identity worked here. So 1.5. We didn't answer this one over here. I should probably put an answer here. Okay. The reason I'm putting answers here is because it says evaluate here in this little spot. Now it's not responding. Just 1 second. Give it a little bit of time to refresh here. What do we have to do? I'm going to make these documents a little bit smaller. I think it's too much ink in one document. Okay. So the same thing could happen here. This is base 32. So when I write this out in my computer here, as long as it doesn't crash on me. Okay, so if I want to write this on my as an identity here, I can say this is log of 1/8 over log of 32. And then you notice the 32 is on the bottom, this 32 is on the bottom. You can punch that in your calculator and you evaluate that. So let's see what that looks like. Let's move my face over here. Log 1/8 divided by log 32. So the answer is negative 0.6. It makes sense that the exponent is negative because you notice that that's a reciprocal. What do I have to raise 32 to the power of to get 1/8? So I have to eventually it's going to have to flip over into a fraction. And it just kind of works out. So let's go and see if we can solve these. Now, you could solve these by using all sorts of different forms. You could use the identity that we just did, you change it to exponential form. You could just plug this into your calculator. All I'm asking for is how do you solve this? So there's a few different ways to solve this question. Like one way is just plug in your calculator. So the log base 3, then we do have that button, so I'm just going to use that button. The log base 3 of 243, I think it was, if I'm correct. Yeah, so it's 5. So x is equal to 5. Other ways you can do it, like you can change it to exponential form, change the base to base 3, and then x is equal to 5 again. Another way to solve this could be change it into that identity because your calculator can't handle base 3. So we're going to do base 10. So you change the identity into those. Punch in your calculator, you get 5 as well. You could change this into, I already did that, change the exponential form. So that's pretty much the 3 ways we could do that one. This one here, you're looking for the x this time. So you're thinking, okay, x to the power of 3 is equal to 1/64. So that's just me changing the exponential form. Now, if I want to solve for x, well, let's take the cube root of both sides. So what is the cubed root of something cubed? Well, the cubed root of something cubed is just x. And the cubed root of 64, I believe, is 4. The reason I'm only worried about what's on the bottom because the cubed root of 1 is 1. So the cubed root of 1 is 1. The cubed root of 64 is 4. I was correct in that. So the x is 1/4. That's one way to solve that kind of question. Another way is to change the base of 64. Doesn't really help us too much. This is probably the best way to do this one. Let's see what else. Yeah, this one here, we're going to do the same thing. We're going to solve for x. So the easiest way to solve for this is just change it into exponential form. It's in log form. So my base is 36. I'm going to raise this to the power. I'm going to switch these two spots. I'm going to raise this to the power of 3/2, and that should find me x. So I go back to my calculator. 36 to the power of 3/2. Boop. 216. I guess I could have done that mentally, because remember that's just the square root of 36 cubed. Okay, and the square root of 36 is 6. Yeah. And 6 cubed, as we said before, is 216. But at any stage down this, you could just punch in your calculator about an answer. Okay, so that's that video. That's all I really wanted to talk about, just how do you change base. So just in case your calculator can't handle the different bases, you could always use there's a log base 10, or the natural log. You could use the natural log button that's just below that to solve those kind of questions. But that's the end for this video. I'll see you next one.